Okay, and this one's question 3 of the challenge questions. So this one we can do with a substitution. So w being x squared plus 1. So if we make x the subject, x is going to be the square root of w minus 1. So if we just sub that in, we get this. Now if we do this to the power of 4, that's the same as w minus 1 squared, which is going to be w squared minus 2w plus 1. Now w minus 1 square rooted and then squared is just going to be w minus 1, so we end up with 2w minus 2. Now this term is the problem term. So if we just collect what we've got w squared. You see that the minus 2w and plus 2w actually cancel out. Then we end up with 1 minus 1, 1. Okay, so I mean this is an answer, but we can write this in a nicer way without the roots. For this you can do it sort of like how you would do a difference of two squares. So if we take our w squared minus 5 root w minus 1 plus 1 and we multiply it by w squared plus 5 root w minus 1 plus 1, then what you'll see is that all of the terms with the root w minus 1 will cancel out. Now we would have to multiply by this on the right hand side as well, but as that's 0, it's still going to be 0. So if we just times that out, we're going to get w to the 4 plus 5w squared root w minus 1 plus w squared minus 5w squared root w minus 1 minus 25 times w minus 1 minus 5 times root w minus 1 and then plus w squared plus 5 root w minus 1 and plus 1 equals 0. Again, as you can see, then we've got this and this will cancel out, and this will cancel out, and then where we've done 5 root w minus 1 times 5 root w minus 1, we end up with just 25 times w minus 1. So in total we've got w to the 4, it's going to be a quartic. We've got w squared here and w squared here, so 2w squared. We've got minus 25w, and we've got plus 25 plus 1, so plus 26 equals 0. And then this is our quartic with the 4 roots given in the question.